So for question 5, the table below shows the elements in the third period of the periodic table, the number of electrons in their outer energy level, their oxidation state in their common compounds, and their melting points. For 5a, is asking us to describe and explain the variation in oxidation state across the period. Now looking at the table, so oxidation state of sodium is +1, magnesium is +2, aluminum is +3, silicon is either plus or -4, phosphorus is -3, sulfur is -2, chlorine is -1, and argon is 0. Now, how can we, again, the command words here is to describe and explain. So, remember, so the number of, so let's describe. So, the number of electron gained or lost, okay, gained or lost, lose, I would say, lose, lost, lost, or the charge on the ion is equal to the numerical value. So, numerical value of oxidation states. Okay, oxidation states. These are the electrons that can be readily accepted or gained. Okay, that's what it meant. So that's what we were able to describe. Now another description that we can have here is that sodium, so if you take a look, they are all plus to silicon. Okay, sodium to silicon, they are plus, meaning sodium to aluminum. You can write it down, sodium to aluminum. Again, we're describing, or silicon, because it's neither loses or lose electrons to form positive ions. Okay, to form positive ions. So from phosphorus to chlorine, as you can see, its oxidation states are negative. So we can say silicon, which includes silicon as well. So silicon, alright, let's put it in a parenthesis because it's either loses or gains 4 electrons. So silicon or phosphorus to chlorine, alright, gains or gain electrons to form negative ions. Okay, negative ions. Since this is only 3 marks, we can mention 3 marks, but apart from the answers that I've mentioned here, we can also say that silicon gains and loses electrons. Again, we're just describing, looking at the given data from the table. So silicon gains and loses electrons, and silicon can form a positive or a negative ion. And we can also say something about argon. Argon neither gains nor loses electrons because argon does not form ions. Please take note that as the oxidation number of a monoatomic ion is the same as the charge on the ion, the variation in oxidation number can be explained by the differences in the charges on the ions, or whether they lose or gain electrons. So if it's a plus, they actually get, again, they lose electrons, just like sodium to aluminum, and same with in contrast with phosphorus to chlorine. We can also say that the variation in oxidation number that you should identify and explain is why some elements have a positive oxidation number or a negative oxidation number, or either a positive or negative oxidation number or an oxidation number of 0. Alright? Now for letter B, the first three elements, sodium, magnesium, and aluminum, are metals. Now again, there's the same command word. Describe the structure of a typical metal. Okay? We have mentioned a lot of things here. You can say first, we can have their positive ions. Okay? They are positive ions. Now, another word for positive ions are cations. If we mention this twice, they just mean 1 point, okay? Or we can also say metallic ions. Any of these reason means 1 point because they just mean the same thing. And we all know they are in metals, okay? They're metals. Therefore, the particles, their particles are arranged in a lattice formation. You can say arranged, alright, arranged in a lattice, alright, in a lattice layers, okay, or in layers. One more thing is that since a metal, we have this C of the localized electrons. Okay, C of electrons will do for this one. Please take note that metal atoms lose their outer electrons to form positive ions. The electrons no longer belong to a particular atom and are said to be delocalized. The electrons are free to move around the structure. Okay, and also when we deal with metallic bonds, it is formed due to the electrostatic attraction between the positive metal ions and the negative delocalized electrons. Metallic bonds are strong and can explain many properties of metals. For letter C, explain why sodium, magnesium, and aluminum are good conductors of electricity. So it's only 1 mark. It's a pretty simple question because sodium, magnesium, and aluminum they're good conductors of electricity because they have mobile electrons. So just like the third bullet there, C of the localized electrons. So you can say that they have mobile electrons. Okay, they have mobile electrons, meaning moving, mobile, and that will let them conduct electricity. And again, it's like same as saying as the delocalized electrons are free to move through the structure, they can carry charge, or electricity is caused by a flow of charge. Hence, metals can conduct electricity. For letter D, which element exists as diatomic molecules of the type X2? So, as I've been mentioning in the class, if the element ends with INE, it's a diatomic molecule. Looking back in the table, we only have one here, which is chlorine. So the answer is chlorine. Okay, chlorine can be written as Cl2. Alright, they mean the same thing. It's just 1 mark. For letter E, silicon has a similar structure to a diamond. Explain why silicon has the highest melting point in the period. So explain. It has the highest, of course, if an element has a highest melting point, we can say that it has a strong covalent bond. Okay, it has a strong covalent bond. Okay. How many marks is this? 2 marks. And we can also mention to get another mark and because silicon is in a giant lattice. Okay, silicon is in a giant lattice. Okay, so it's strong, or it's a macro molecule. Maybe we can refer to like the combination of silicon to oxygen. So we have silicon dioxide, has lots of very strong covalent bonds, and it extends in a giant lattice and no intermolecular forces. So it has similar properties to a diamond. So the many covalent bonds require a very large amount of heat energy to break the lattice. Thus, it has a very high melting point. For letter F, sodium chloride is a crystalline solid with a high melting point. It dissolves in water to give a neutral solution. Phosphorus trichloride is a liquid at room temperature. It reacts with water to form an acidic solution. Suggests an explanation for these differences in properties. It's only 2 marks. So again, we can say that sodium chloride is a combination between a metal and a non-metal. Therefore, it's an ionic compound. While phosphorus trichloride, okay, is a combination between 2 nonmetals, meaning it's a covalent bond. So we can mention that. So we can write it down like sodium chloride, okay, is ionic, and phosphorus trichloride is covalent. Okay, is a covalent. So we need 2 reasons here. We can also compare that ionic bonds are strong and intermolecular forces are weak. Okay, we can mention that. For ionic bonds, okay, ionic bonds are strong and intermolecular forces are weak. We can also say that based from the problem, it says sodium chloride is a crystalline solid with a high melting point, and sodium chloride can be dissolved in water, while phosphorus trichloride is a liquid at room temperature. So it reacts with water form an acidic solution, meaning we can say here that PCl3 reacts with water. Okay, reacts with water, and sodium chloride, okay, does not. Sodium chloride does not. I think at least any 2 of these 3 possible reasons or explanation can give you 2 marks for this question. So that's for question 5.